Z, since ABCD is a parallelogram, therefore diagonals of parallelogram, that is AC and BD, bisect each other. AC और BD bisect करते हैं diagonals of a parallelogram. That means they meet at the common point. Now, therefore, midpoint of AC is equals to midpoint of BD. So, midpoint of AC, midpoint of line x1 plus x2 upon 2, y1 plus y2 upon 2 and z1 plus z2 upon 2. A has coordinates 4, 5, 10. B has coordinates 2, 3, 4. C 1, 2, minus 1. These are the coordinates of this. Now AC 4 plus 1 by 2, 5 plus 2 by 2, 10 minus 1 by 2. Coordinates of BD 2 plus x by 2, y plus 3 by 2, z plus 4 by 2. Midpoint of AC and BD are equal, so equate the coefficients. X plus 2 by 2 is equals to 5 by 2. Y plus 3 by 2, 5 plus 2 is 7 by 2. Z plus 4 by 2 is 9 by 2. 2 will get cancelled from all these equations. So what we get? X is 5 minus 2, 3. 7 minus 3, 4. 9 minus 4, 5. So the coordinates of D are 3, 4 and 5. Coordinates of D are 3, 4, 5. Is it clear? सबसे पहले हमने लाइन AB और BC की इक्वेशन निकाली वेक्टर और कार्टेशियन फॉर्म में. Line passes through 2 points, so we use the formula R vector is equals to A vector plus lambda B minus A for both AB and BC. Then change the equation into Cartesian form. Now we want to find the coordinates of D. Since it is a parallelogram, diagonals of parallelogram bisect each other. Therefore, midpoint of AC and BD should be equal. If they are equal, then we can find the value of x, y, z. Therefore, coordinates of D are 3, 4 and 5. Now the next one, find the vector equation of line passing through a point with the position vector. Passing through a point 2i minus j plus k and parallel to the line joining points minus i plus 4j plus k and I plus 2j plus 2k. Now we know that vector equation of line that is passing through one point and parallel to the line. Parallel to line this which is formed by joining 2 points. Now we want to find P vector that will be equal to I plus 2j plus 2k minus I plus 4j plus k. सबसे पहले हमें इस लाइन का पोजीशन वेक्टर निकालना होगा. Let this line, this is the point A, this is BC, so BC vector that is equals to B vector. Now I minus plus 1, 2 minus 4, 2 minus 1. So B vector is this, A vector is 2i minus j plus k plus lambda 2i minus 2j plus k. This point is important in this question, that the line which is parallel to vector that is made by joining these 2 points. So our vector is 2i minus j plus k plus lambda this. Also find the Cartesian equivalence of the function. Cartesian equivalence of this equation निकालना हमें. So for Cartesian equation क्या करेंगे हम? For Cartesian equation plus zk. Put the value of r vector. xi plus yj plus zk, 2 plus 2 lambda I cap plus minus 1 minus 2 lambda j cap, 1 plus lambda k cap. Now equate the like coefficient terms. What we get? X is equals to 2 plus 2 lambda, y is equals to minus 1 minus 2 lambda, z is equals to 1 plus lambda. From these three equations, find the value of lambda. X minus 2 upon 2, y plus 1 upon minus 2, z minus 1 upon 1. Now all these values are equal to lambda, so equate these values. X minus 2 upon 2, y plus 1 upon minus 2, z minus 1 upon 1. We can write it as x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. So this is the Cartesian equation of this equation. So this is the Cartesian form. हमने जो क्वेश्चंस किए इसमें हमें वेक्टर फॉर्म गिवन थी, या हमें वेक्टर फॉर्म निकाल के उसको कार्टेशियन फॉर्म में चेंज करना था. नेक्स्ट क्वेश्चंस हम करेंगे जिसमें हमें कार्टेशियन फॉर्म गिवन होगी, या फर्स्ट हमें कार्टेशियन फॉर्म में इक्वेशन निकाल के देन उसे चेंज करना है वेक्टर फॉर्म में. सो लेट्स स्टार्ट विद द अदर वन. फाइंड द कार्टेशियन इक्वेशन ऑफ लाइन पासिंग थ्रू पॉइंट्स A 2 minus 1 3, B 4 2 1. Also reduce it to the vector form. सबसे पहले हमें कार्टेशियन इक्वेशन ऑफ लाइन निकालनी है. If this line is joining by 2 points, line passes through 2 points, then what is the Cartesian equation? X minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. This is the Cartesian equation of line that passes through 2 points. Now 2 points are given. So what will be the Cartesian equation? X minus, this is x1 y1 z1, x2 y2 and z2. x2 minus x1, y minus y1, z minus z1. Now x2 minus x1, y2 minus y1 and z2 minus z1. So what we get? X minus 2 upon 2, y plus 1, 2 plus 1, 3, z minus 3 upon minus 2. Now this is the Cartesian equation of the line. Now we want to find the vector equation. So let it be equal to lambda. So we get x is 2 lambda plus 2, y is 3 lambda minus 1, z is minus 2 lambda plus 3. यहाँ तक निकालने के बाद for vector equation, to find vector equation, then we have to put this equal to lambda. This is the Cartesian equation of line. Now for vector equation, put this Cartesian equation equal to lambda, then find the value of x, y and z. Let r vector is equals to xi plus yj plus zk be the position vector of any point on a line. Be the position vector of any point on the line. Then put the value of this. R vector is 2 lambda plus 2 I cap, 3 lambda minus 1 j cap, minus 2 lambda plus 3 k cap. We can write it as 2i minus j plus 3 k cap. Take lambda common. 2i plus 3j minus 2k. So this is of the form r vector is equals to a plus lambda b minus a vector. So which is the required vector form? Which is the required vector form? Is it clear? सबसे पहले हमें पॉइंट्स गिवन थे, हमें उसकी कार्टेशियन इक्वेशन निकालनी है. Cartesian equation of line when it passes through 2 points, that is this. Put the value of x1, y1, x2, x1, y1, z1, x2, y2, z2. Then we get the Cartesian equation of that line. Now we want to reduce it to the vector form. To reduce it to the vector form, let this Cartesian equation equal to lambda. From here, find the value of x, y, z. Let r vector is xi, yj plus zk be the position vector of any point on line. Then put the value of x, y, z here and write the equation in this form. Note it down. Now the next question. The Cartesian equation of the line are 6x minus 2, 3y plus 1, 2z minus 2. Find its direction ratios and also find the vector equation of the line. We know अगर हम Cartesian equation line की लिखते हैं, so that is of form this x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. Coefficient of x, y and z are unity. So first make the coefficient of x, y, z unity. Take 6 common, x minus 2 by 6, 3 common, y plus 1 by 3, 2 common, z minus 1. So we can write it as x minus 1 by 3. Divide this whole equation by 6. Y plus 1 by 3, 3 by 6, that is 2. 6 से divide किया 2 by 6, so 1 upon 3. So this is the Cartesian equation. Now we have asked about the direction ratios of the line. So the direction ratios are 1, 2 and 3, and the line passes through point. Line passes through point 1 by 3, x minus x1, y minus y1, z minus z1. We can write this as y minus minus 1 by 3. So the line passes through point 1 by 3 minus 1 by 3, 1, and its direction ratios are 1, 2 and 3. Now line passes through this point, so its position vector is 1 by 3i minus 1 by 3j plus k, and has direction ratio this. So this is b vector, I plus 2j plus 3k. Now the vector equation of line that passes through a vector and whose direction is given, that is r vector is equals to a plus lambda b vector. A vector is 1 by 3i minus 1 by 3j plus k plus lambda I plus 2j plus 3k. So this is the vector equation of the given line. Clear? सबसे पहले हमें coefficient of x, y at unity बनाने हैं. After that the biggest term is 6, so divide the whole equation by 6, or we can say that take the LCM of 2, 3, 6. जो भी इन टर्म्स का LCM आए उससे हमने पूरी इक्वेशन को डिवाइड कर दिया. Then we get the direction ratios as 1, 2, 3, and the line passes through point 1 by 3 minus 1 by 3 and 1. Now if a line passes through a vector and whose direction is given, that is b vector, then vector equation is r vector is equals to a vector plus lambda b vector. Then put the values of a vector and b vector. Now the next question. Find the direction cosines of line. The line given is x minus 2 upon 2, 2y minus 5 upon minus 3, z is equals to minus 1. Also find the vector equation of the line. First we want to find the direction cosines, then the vector equation of line. We can write it as this 2 common y minus 5 by 2 upon minus 3. When it goes on that side, z plus 1 upon 0. Z plus 1 upon 0. So x minus 2 upon 2, y minus 5 by 2 upon minus 3 by 2, z plus 1 upon 0. This is the Cartesian equation of line, जिसको हमने solve किया. Now this line passes through point. This line passes through point 2, 5 by 2 and minus 1. We can write it as z minus minus 1. 2, 5 by 2 and minus 1. And direction ratios are proportional to 2 minus 3 by 2, 0. Now we want to find the direction cosines. Direction cosines are a upon square root of a square plus b square plus c square, b upon square root of a square b square c square, and c upon square root of this, where a, b, c are direction ratios. First find the square root of this term, 2 square minus 3 by 2 square plus 0. So 4 plus 3 square is 9 by 4, 4 into 4 16, plus 9 square root of 25 by 4, that is 5 by 2. So the direction cosines are 2 upon 5 by 2 minus 3 by 2 upon 5 by 2 and 0 upon 5 by 2. So the direction cosines are 4 by 5 minus 3 by 5 and 0. 4 by 5 minus 3 by 5, 0. Now we want to find the vector equation of line that passes through point this and whose direction is given as this. So this is a vector. For vector equation, a vector क्या हो गया? लाइन किसमें से पास कर रही है? इस पॉइंट से. So 2i plus 5 by 2j cap minus k cap. Direction ratios are this. So b vector is this. Now vector equation of line that passes through a point and whose direction is given as b vector. So r vector is a vector plus lambda b vector. Plus lambda b vector is 2i minus 3 by 2j plus 0k. So this is the vector equation of the given line. Now the next one, show that the points whose position vectors are 5i plus 5k, 2i plus j plus 3k and minus 4i plus 3j minus k are collinear. Let the given points be P, Q and R whose position vectors are a vector as 5i plus 0j plus 5k, b vector is 2i plus j plus 3k and c vector is minus 4i plus 3j minus k. Let p, q, r be the 3 points with position vector a, b and c. Now if we want to write the vector equation of line which passes through 2 points is lambda a vector plus lambda b minus a vector. Put the value 5i plus 0j plus 5k plus lambda b minus a. 2 minus 5, 1 minus 0, 3 minus 5. Now this is the vector equation of line that passes through 3 points. Now if these 3 points are collinear, then this point should satisfy this equation. So instead of r vector, put the value of c vector minus 4i plus 3j minus k, 5 minus 3 lambda I cap, 0 plus lambda j cap, 5 minus 2 lambda k cap. Let this as equation 1. After that, write that line. If these points are collinear, then the point R must satisfy the equation 1. अगर इस इक्वेशन में R की जगह हमने C वेक्टर की वैल्यू पुट करी और तीनों इक्वेशन से हमें लैम्डा की वैल्यू सेम मिली, then these points are collinear. So minus 4 is equals to 5 minus 3 lambda. On equating like coefficient terms, 3 is equals to 0 plus lambda, minus 1 is equals to 5 minus 2 lambda. Find the value of lambda. Minus 4 minus 5 minus 9. So we get lambda as 3. Minus 1 minus 5 minus 6. So lambda is 3. Lambda from all these three equations have same value. Therefore, the point P, Q, R are collinear. Since lambda has same value from three equations, therefore the points P, Q, R are collinear. Now next one.